Hi there. So in the previous videos, we've talked about complex functions or functions of complex variables as sort of transformations from the z-plane to the w-plane, and we looked at a few examples. In particular, if we have a complex variable and we add a complex constant to it, the effect is that of a net translation of the complex plane from the z-plane to the w-plane. And likewise, if we have a complex variable z and we multiply it with a complex constant, the net effect is rotations and scalings of the complex plane. Now we sort of worked out these examples with working with a unit square in the z-plane and saw the effect of translations and rotations and scalings. Subsequently, in the next video, we introduced the equation for a circle in the complex plane. So in this particular video, let's take an example where we look for well, there are three different features that we'll work with. First of all, we'll work with a circle in this case, and in particular, what we'll do is we'll try and we'll look for an inverse question in the sense that in this case, let's say we are not being given a mapping, but what we've been given is what. So let me just read the question. So the question is, find a mapping that transforms a circle in the z-plane of the form mod of z minus 1 equals 1 to another circle in the w-plane of the form mod of w minus 3i by 2 equals 2. So this is an inverse question. We need to find the particular mapping that will take one circle, one kind of a circle, to another kind of a circle in the w-plane, from the z-plane to the w-plane. And we'll see that in this process, the kind of mapping that we're working with is actually a composition of translations and rotations and scalings that we have looked at before. So let's see how we can go about approaching this question. So first of all, let's draw what the information that we already have. So we've been given the circle in the z-plane, and if you recall from the previous video, and I put a link just to review the equation for a circle. So the equation is mod of z minus 1 equals 1. Now this is a circle in the z-plane which is centered at 1, 0 and has radius of 1 unit. So it will be a circle that looks like this. It passes through the point 2, 0, center is 1, 0, and it passes through the origin. So this is the z-plane, and we want to transform this into a circle in the w-plane whose center is 3i by 2, so it's on the imaginary axis, let's say somewhere here, and radius is 2 units, so it will be a circle that should look something like this. Okay, and we need to find the mapping that will take us from this circle to this circle in the z-plane to this circle in the w-plane. So what is w as a function of z? That's the question that we want to answer. Now notice that there are, in this particular transformation, there are two things that we can already see that's happening. First of all, the center of the circle has been shifted from being at 1, 0 on the real axis to 3i by 2 on the imaginary axis. So one of the effects that we need to look for is there is some kind of a translation. And secondly, the circle in the z-plane has radius 1 unit, whereas the circle in the w-plane has radius 2 units. So there is a scaling, right? So in effect, what this is telling us is that the mapping that we're looking for should be some composition of both addition by a complex constant and multiplication by a complex constant. Now multiplication by a complex constant also causes a rotation. However, since we are working with a circle, which is a symmetric figure, we know that the effect of rotation of a circle will still keep it a circle of the same form, and so therefore we do not see the effect of a rotation in this particular case. Okay, so now one of the ways of approaching this problem is to actually break it down into a sequence of steps and then sort of work out or a sequence of mappings such that the composition of all those mappings gives us the resultant figure. So let's see how we can do that. And let's get rid of this figure for now. So as a first step, it's often quite useful to transform this circle which has a center 1, 0 to the origin. So let's just transform it to the origin because then it becomes easier to work with the circle. So how do we transform this circle from the point 1, 0 to the origin? And this simply means that we can take this axis and shift it by 1 unit forward, or we can take the circle and shift it backwards. Now, if you recall the video on translations, then you remember that W equals Z plus C is a translation of the complex plane by C units. So in this case, if we want, and we can think of it in two ways. Either we are shifting the coordinate axis by C units backwards, or we are taking the figure and shifting its C units forward. So in this case, if you want to shift the circle 1 unit backwards, then the mapping that we are looking for is of the form W1 equals Z minus 1, because if we shift the circle 1 units backwards, its center will be at the origin. So then we have a circle that looks like this, minus 1 comma 0, by defining a mapping which is W1 equals Z minus 1. And I'm using W1 here because this is like an intermediate step. We want a final mapping W as a function of Z, but for now this is an intermediate step that takes us from a circle that's at of radius 1 unit centered at 1 comma 0 to another circle of radius 1 unit centered at 0 comma 0. So let's write that as a first step. So as a first step, let's do a mapping W1 equals Z minus 1. Now what we can do is, we can take this circle and scale it up so that we achieve our objective of having a new circle whose radius is 2 units. And this we can do by simply defining a new mapping W2, which is 2 times Z minus 1. And what that will give us is, so if this is the first step going from here to here, as a second step, let me just draw the second step here. So after the first step, after this step, we have a circle which is at the origin and has radius 1 units. So we have this, where this is the origin. And as a second step, we can scale this circle by 2 units so that it is still at the origin, but its radius is 2 units. And that is the mapping W1, which is, or W2, which is 2 times W1. We can think of this as W1 and W2. And this is the origin. Now all we need to do to achieve this circle is, we already have a circle that has radius 2 units. All we want now is that the center of the circle should be at 3i by 2. And so we need to shift this up. We need to take the circle and shift it up by 2 units. And that again involves a simple translation by 2 units along the imaginary direction. So a final mapping W will be W2 plus 3i divided by 2. Since W2 is 2z minus 1, the overall effect of the mapping is 2 times z minus 1 plus 3i over 2, and this gives us 2 times z minus 2 plus 3i divided by 2. And this will give us the final circle, which will look like it is centered at 3i over 2, and it has radius of 2 units. This one, right? And the mapping that achieves this is 2 times z minus 2 plus 3i divided by 2. Now notice that this mapping is of the form W is some complex constant az plus some complex constant c, and in this case the complex constant a is 2 and c is so we can write a as 2 and c is minus 2 plus 3i divided by 2. So this is a mapping which is a composition of both a rotation and a scaling plus a translation. This is what we had anticipated earlier. And just to recall, we do not see the effect of a rotation because we're working with a circle which is symmetric, and so even if we rotate it, there is no net effect. So all we see is the effect of scaling and translations. And in fact, mappings of this form do preserve circles and parallelograms quite generically, and they sort of are a subset of a very important class of mappings that we'll talk more about in future. But if you're given a question of this form and we need to find out a transformation that takes us from one figure to another, the general idea is to break it down into a sequence of steps and like work out one step at a time and see what is the overall effect of the composition of all those steps. In this case, we needed to work out 3 steps: a simple translation, a scaling, and then another translation. So hope this is of some use, and let's continue talking more about many more things. See you there.